In this video, I introduce RNN encoder-decoder machine translation model. RNN is a sequence-to-sequence model that maps the input sequence to output sequence. Here, we use RNN as a machine translation model that translates a source sentence in one language to a target sentence in another language. RNN model uses current input and the previous hidden state as the input to the output layer to generate a probability distribution over a corpus. For example, here this is the WY, and this is the hidden state vector H. We use the products as the input to softmax function to produce this probability distribution over a corpus. Then now we select from this distribution, select one as the output at a time t. Then we use this output to generate a sentence through a language model. However, this RNN model has two disadvantages. One is when we predict the current output, we only consider the previous input information. Actually, in most of the cases, we need to consider all the input information to correctly predict the current output. Also, we need the previous output together to predict the current output. To overcome these two disadvantages, we introduce RNN encoder-decoder machine translation model. We use encoder to encode the input sequence into a context vector. And then based on this context vector, the decoder uses this previous output as the current input from this context vector C and together with the previous hidden state to generate the probability distribution over the corpus. Use this way, when we generate this probability distribution over a corpus, we consider all the input sequence information and all the previous outputs together to correctly or accurately predict the current output. The key part is how can we make sure this C, this context vector C, can memorize all the input information. So we use GRU as the hidden state. That means we incorporate the GRU into the hidden states in the decoder, make sure this context vector C can memorize all the input sequence information. Because this encoder is a regular RNN model, so we can use the regular GRU incorporate into this hidden state to make sure this context vector can memorize all the input information. However, in the decoder, because we have this previous output is current input, and we have this context vector as an input, so it's different from the regular RNN model. So when we use the GRU into this hidden state in the decoder, we need to modify the updated equations. Let's see more details. First, we use the previous output through a embedding method. We get this embedded previous output as a current input here. And we use the context vector here as the bias. So we add this C in the bias position. And then we define the reset gate that is used to control the information from the previous hidden state to the current cell. And we use the update gate to control the outgoing information from a current cell to the next cell. And then we use this candidate hidden state and the previous hidden state to define this current hidden state. And then this candidate hidden state is defined by using this current input and the previous hidden state gated by this reset gate. And then we use regular GRU update equation to update each gate in the GRU cell. For more details, please check with this reference. Thank you.